Today I am going to talk with you the longitudinal data and its analysis. You probably are aware of this particular topic because of its tremendous use in various medical field and other social science areas. So, people are randomly using this kind of model, and it is quite different from what you have learned the linear models and its analysis. Incidentally, what happens that in particular linear models, people are going to use the analysis of variance, analysis of covariance and other things, but in this context we are going to show that merely using analysis of variance or covariance will not suffice the whole inference procedure. The reason is that over time points the observations are collected and they are dependent, that we ignore in the context of analysis of variance or analysis of covariance. Now, we will discuss this in two sessions. In my first session, I will speak mainly on its application in various fields, and in the second session, I will go for all kinds of methodological aspects, like starting from the older approach to the current approach that we are going to use. All right. So, let us start the first session now. So, longitudinal data, essentially an introduction of that. What is longitudinal data? I will speak on that first of all. Then how does it differ from the easily available time series data? People go for that. I will find out that I try to explain the difference between that. And finally, what is more important is that where this kind of longitudinal data is used. All right. Now, what is time series data? You probably know that it is basically collection of many data points over time from a single source, such as from a person, some region, some country, or any other area, etc. On the other hand, if you look at the longitudinal data, it is essentially a collection of a few observations, not like time series data, many observations. It is just a few observations over time from many sources, not from a single source, as I mentioned in the case of time series data. So, such as a few blood pressure measurements from many people. So, you like in the pathological lab, from many people the blood pressure measurements are collected and it is being observed over subsequent points of time, 3-4 points of time. So, this is basically the longitudinal data. All right. So, let us go through some examples to motivate where longitudinal data is used. See a situation where the treatment of pain after surgery is being looked into. A batch of patients, when surgery is done, you can stick to the particular kind of surgery and the homeopathy treatment is being given, and another batch is being given the placebo. And let us look at the difference between these two. So, if we look at the first graph, where on the day of surgery you can see that over time points, that first hour after surgery, the first batch, the homeopathy treatment applied to those, the first batch is considered, and the VAS means the visual analog scales. Essentially, it is used for pain assessments through questionnaires on the psychometric response scale. Okay. So, these observations are recorded, or outcomes or responses are recorded after surgery, and every hour it is being recorded for the two batch of patients, one being applied homeopathy and the other group has been applied placebo. Okay. So, after on several hours you can see the pain goes on increasing and the placebo and homeopathy treatment functioning almost similar manner. It goes on increasing up to the 6th hour, or maybe up to, yes, up to 6th hour, and then after that it goes gradually down, down. So, this is on the day of surgery before the bedtime it is recorded, right. So, virtually if you look through the graph, you see that for the two batch of students of two batch of patients, the homeopathy treatment is functioning almost similar to placebo. On the other hand, if you look at the subsequent days, the graph shows like from the day 1 to day 7. So, immediately after the day of surgery, the patients are observed, and you see that in morning and evening the VAS scores are recorded and it is being plotted there in the graph. You see that the homeopathy and as well as the placebo providing almost the similar behavior. So, it goes on down, down and down, down, down and down ultimately. Okay. So, where this longitudinal data comes, we come back to that longitudinal data, because in the first day you observed it for several hours. The outcomes here is the assessment of pain, to what extent the patient is suffering from the pain, how severity of is the pain. So, that is being observed, and that over time points, right. So, when you see this, that the graph actually for both the first figure and the second figure shows the mean pain assessments. So, what I am doing here is that I observed the pain assessments or pain severity for say 1000 patients who has been applied the homeopathy treatment to reduce the pain after surgery, and again sort of maybe 1000 or 12, it is not necessary that the number should be same. Again a batch of patients are taken up who has been given placebo, and based on their questionnaire the pain assessments are made. So, now what we do is that for every hour, based on the 1000 or maybe 1200 patients in the two groups, we take the mean pain assessments and then plot that on the graph. So, this is how the mean pain assessment graph has been shown for the patients over different hours in the first graph, and over different days and over different half, like the morning and evening, this has been shown. So, this is what is longitudinal data, where the data observed over time points, different time points. So, as you see that if you think of, instead of the mean response in the first graph or the second graph, if you consider a person, individual patient's pain score or pain assessment, you see that you are observing it for the same patient over different points of time. So, it should be that the assessment over different points of time, or the scores or the pain score or the severity of scores are essentially correlated, because it is dependent on the previous hours measurement or scores. All right. So, as I said that instead of mean response, if we consider individual response and take it as suppose the individual response, we see that the over different hours the responses are dependent. That is what the longitudinal data playing the major role. It's different from the standard linear model, where the observations are independent, we do not care for the time points, right. And here also in the second graph, over different days and different halves, when you consider this, the responses are all dependent. So, this is how the longitudinal data occurs, and one has to take care of this particular dependency to make a stronger inference. Consider the second example. You might be knowing divalproex is a kind of medicine or drug that is used for the patient suffering from depression. You know that bipolar depression is a kind of mental condition where the patient sometimes becomes so happy, excited, and sometimes get depressed. So, this is one particular situation where I want to show that the longitudinal data is being used. I mean, data analysis has to be done for that kind of situation, where a batch of patient has been given the divalproex medicine and another batch is given placebo, just to see that whether the divalproex is really effective in reducing the bipolar depression of patients. All right. So, you see that in the x axis over the different weeks, actually starting from the baseline, then you have first week, second week, and so on up to 8th week. The observations, the outcomes are plotted. The outcomes are Hamilton rate scaling for depression, mean change. So, once again I come to the mean, because I cannot show the so many patients suffering from all these depression and the scores for them. So, rather than doing that, I take the mean of all the patients who has been suffering from this kind of disease or disorder, and the red shows the patients who are given this placebo and blue shows the patients who are given the divalproex medicine. So, this is the mean response curve for the placebo patients, and the blue is the mean response curve for the divalproex patients. All right. And you see that over different time points, over different weeks, the mean responses, mean change over the depression scoring has been plotted. Third example is the pint of milk versus control on bone acquisition in adolescent females. You know the pint, the word pint means some amount of milk, usually 1/8 of a gallon of milk. So, some amount of milk is given to adolescent females. You know that adolescent females, they are most of the females are suffering from this I should say that the kind of deficiency in bone acquisition. So, this is whether milk is really effective in increasing their bone density or bone mineral content. We are going to look into that. So, this is the control who are not given any particular medicine or not given milk, I should say rather, and the another group who are not given any particular medicine and given only some amount of milk every day. So, this is again the mean response, mean percentage increase. The first graph actually gives the total body bone mineral content. That means, per unit length of bone, the mass of mineral available. So, that is measured for a group of adolescent females, and the average mass is being plotted over different months. So, starting from baseline to 6 months, then 12 months, then 18 months. So, equal interval of time. All right. So, this is the first graph is the total body bone mineral content, and the second is total body bone mineral density. You know that mineral density means the per square centimeter to what extent the calcium and other minerals are deposited. Okay. So, that measures the whether the person has been suffering from any kind of bone disease or not. All right. So, the higher the mineral content or higher the mineral density, the better is the patient's bone condition. So, over different successive months actually the observations are recorded, and as I said that this is basically these two graphs are mean responses, mean percentage increase. So, if you look through the black line in both the figures, what you see? You see that at least after 6 months the patients are getting some better mineral content because of using milk, because you know that the black line is the patients who have been given pint of milk, and the dotted line is the patients who are control group. All right. So, this is another situations over different months you observe the mineral content or mineral density, and then the mean percentage increase is given there in the graph. So, this is another example for longitudinal data. Finally, one more. This is the counseling versus control on smoking in pregnancy. So, the red is the counseled group, and you see that significant improvement is observed from the graph for those mothers who are counseled actually, and over different time points, over different months during the pregnancy period. So, significant reduction can be seen through the red lines for counseling. So, this is the advantage of counseling, at least this graph shows, right. And so, it is again a longitudinal data, because in the y axis you see the number of cigarettes consumed by the mothers over different weeks, and in the x axis you see over different time points the baseline, then 3rd month, then 6th month, then 12 months. What is how many cigarettes are being taken by the mothers. So, that is being another longitudinal data, because as you see that over different time points the patients, I should not say the patients, the pregnant mothers are observed. All right. Let us now see the numerical structure of this longitudinal data. In the broad form you can see that the individuals, there are 6 individuals, every individual is observed over time points. Look, at the very beginning I said that in the longitudinal context there may be many individuals who are observed over a few time points. So, I take just for illustration 6 individuals observed over successive time points. In this connection I just mentioned that there may be the situation that couple of observations, couple of outcomes are missing. We are going to go for that later on, but just have a look at the longitudinal data in broad form and also in long form that is written in the other way around. So, for individual 1 you see that over time points 1, 2, 3, 4 the scores are there, and similarly for individual 2 and so on. All right. So, this is the data presentation. If you look to the profile plots, so the profile plots of the previous long form data is essentially looking like that. As I said that over different time points, so there are 4 time points 1, 2, 3, 4, and the person's scores are being observed like this, 2, then 3, then 4 like this. So, different individuals are observed, their behavior is different, some goes down and go up, some goes not that much down and not that much increase. So, but there is a change in the 3rd time point and the 4th time point, right. So, this is the profile plot. I can show you some other plots also, but if you look at this mean response plot, what is mean response plot? I said that in the profile plot several individuals are there. I just show We have 6 individuals. So, I just show 6 individuals plot, but if there are 1000 individuals, say 1500 individuals, what you will do? Rather than going to this way or profile showing the profile plots in the same graph, we can go for the mean response. So, for all these individuals, you take the mean response, plot them over different time points and get the figure like that. So, this is the figure that you obtained in the previous diagram, where the individual plots are there, right. So, this is the mean plots. So, when you superimpose that, what you superimpose? We superimpose the mean plot, and this shows a figure like that. This is the superimposed plot, all right. So, and then the smooth curved can be shown, can be drawn this way. This is the mean smooth curved and the superimposed curved once again. So, let us now make little bit change. You have two groups rather than a single group. Now, I consider, like as I said, that placebo versus some Divalproex, placebo versus another kind of medicine. So, you have two groups. So, for each group you have 3 individuals and they are observed over different time points. So, you have data like this, and for hypothetical data here B, I mean the second group B, you have again 3 individuals. This is a very idealistic, very simple data set I am showing, but people can face more complicated data where these are not balanced. I said that some of the individuals are not observed over whole time points, some of the individuals are have missing data and other things. We will come to that later on. And they are profile plots for the different groups. Now, I consider in terms of 2 different groups the plots. So, for their profile plots are plotted here, and you can see the mean response plot. So, for A group the red line, for B group the blue line, and the questions that one can arise that overall are there significant differences between time points. From plots you can see that it looks like there are some differences time 3 and 4, right. And the second question that one can arise that overall are there significant changes from the baseline? The answer is again, if you look at time 3 and 4, it is different from the baseline, right. And if you look at the groups, for the 2 groups, do the 2 groups differ at any time points? Certainly, they differ at the baseline. If you go back to the previous figure, you can see that they differ at the baseline, but there are some differences in most of the time points. So, the 2 groups looks to be different at different time points. Final question is, do the 2 groups differ in their response over time? So, their response from the plot actually what you can see, but analytically one can show, mathematically one can show is there any difference or not. So, these are basically the inferences we are going to do that, right. So, the answer is from plots their response profile looks similar over time, though A and B are closer by the end. Okay. I am not going back to the graph, but I think you can recall these graphs.